Hey guys, welcome to today's tutorial. We're introducing the chapter or the topic of probability. So this won't be too long because this is pretty much the same things we have done in previous years. I'm just going to give you a few little bits and pieces. So first of all, what does probability refer to? Okay, so probability, hopefully remember, is all about the chance of an event occurring. So the probability is the chance of an event occurring. Now let's take an example. Let's say, for example, we want to find the probability, we want to look at the probability when I roll a dice, and we can have certain things can occur. For example, we might say the probability that I roll a 6, or we might say the probability that I roll an even number. We might even say the probability of not a 3. So there are a few things we want to kind of discuss when looking at probability. The first, I guess, is how it's written. Okay. Now, in each of these examples, the P represents probability. And then, of course, in the brackets is what we refer to as the event that's occurring. Now, if I want to answer that first one, hopefully we remember that we can find the probability of an event by saying the number of favorable outcomes divided by the number of total outcomes. So the number of outcomes. So what do I mean by that? So if I look at the probability of a 6 occurring, I would ask the question, how many 6s are on the dice? Well, there is only 1 6 on the dice. And then for my total outcomes, I would say, well, how many outcomes are there? What numbers or how many numbers can I get when I roll a dice? And there are 6 numbers on the dice. Therefore, we have the probability of 1 in 6. Now, as a side note, when I'm talking about the actual outcomes, so in this case, we might call it as 1, 2, 3, 4, 5, and 6. We actually can refer to this as our sample space. So they're all the different outcomes that we've got. Now, the next question is the probability that I get an even number. So once again, I go back to this little table here, a little formula, if you will, that the probability of getting an even number, well, what are the favorable outcomes? Well, we have got a 2, we've got a 4, and we've got a 6. Therefore, there are 3 favorable outcomes out of a total of 6 outcomes, which can be simplified, of course, to be given a half. And then, of course, that last one at the bottom there, which says the probability of not a 3. Well, not a 3 would be the 1, would be the 2, would be the 4, would be the 5, or would be the 6. Therefore, there are a total of 5 favorable or possible outcomes out of a total of 6 outcomes. So we now have 5 over 6 as our answer. So again, that's a really quick overview of how we find the probability of a particular event occurring. Now, one of the questions someone might ask as well is, okay, let's take a look at that answer for the probability that I get an even number. Can I also write that as a percentage? Well, absolutely. That could be written as 50%. Could that be written as a decimal? Absolutely. That could be written as 0.5. And of course, we've already written that as a fraction as 1/2. So we can have a percentage, we can have a decimal, or we can have a fraction. And of course, on our calculator, that SD button will allow me to calculate those very, very quickly. Doesn't really matter which one you use. We tend to use fractions a lot, but we also use decimals. We don't tend to use percentages as much, but of course it's still correct. If it's not a nice decimal, for example, you might get something that looks like, let's say 0.333, and that keeps on going forever. We know that to be either 0.3 recurring, or we like that to write that as 1/3. And often I will say, if it's not a nice decimal, if it's not a terminating decimal perhaps, then I like to use the fraction. Otherwise, decimals are fine to use. Okay. We can also, I guess, take a slightly backward step, and we can use words, of course, to describe probability. Now, for example, I remember this old question we used to always have, where you would be given a number between 0 and 1, and you were asked to write words there describing probability. I might put a 0.5 in between. Now, of course, when I do that, like look at 0.5 and a half, we might remember the words such as even chance, or 50-50, if you write it in words. We might say things like certain, or words like impossible. We might then say things like likely and unlikely. And they're all what we refer to as words of probability. And of course, that's again reinforcing the fact that probability sits in between 0 and 1. Okay, where 1 is 100% and 0 is 0%. So of course, back in year 7 and year 8, we often use words to describe probability. Now we can in fact use values, I guess, and that's something that we would like to do. The only other thing I'm probably going to mention, I've already kind of looked at it there in part 3, where we said the probability that we do not get a 3, that can be written as or called a complementary event. And that's the event that something does not occur. Now, for example, we know not a 3 meant the probability of getting a 1, a 2, a 4, a 5, or a 6. Now, of course, that takes a little bit of time to rewrite that as 1, 2, 4, 5, and 6. So sometimes people will say, well, that's a probability of 1 minus getting the 3 on out of 6. Okay, and that you can see very clearly is 5 on 6. So often we can call a complementary event is 1 minus. So sometimes we like to do this as well. We might do P dash like that, and that's 1 minus the probability of my event occurring. Basically, if we know what that event is, we take it away from one whole, then we get the rest of it left over, and that can be useful. Before we finish off, because I don't want to spend too much time on this, there are lots of questions here, and I'm pretty sure you're going to get most of this stuff pretty right. Just a couple of little things. Often we're asked about prime numbers. So if we use that same example of rolling the die, what's the probability of getting a prime number? And the only reason people struggle with this is because we can't remember what a prime number is. So I think prime numbers, for example, the sample space of a prime number will be numbers like 2, 3, 5, 7, not 9 of course, but 11 and 13. They're numbers that only have 2 factors, okay, 1 in itself. Remember, 1 is not a prime number. So if I looked at a dice, we've got a 2, we've got a 3, we've got a 5, therefore it's 3 and 6, which is 1 in 2 chances. Okay, and I guess the only other thing I wanted to mention is you might get questions about cards. So remember, in cards there are 4 suits. We will have the hearts, we have the diamonds, we have the spades, we have the clubs. Now with that, these are red cards and these are black cards. So we might be asked, first of all, how many suits are there? How many cards are in each suit? Well, remember, there are 52 cards in a normal deck, excluding the jokers. Okay, so if we talk about that, that means there are 13 cards in each suit, which means, of course, there are 26 red and 26 black. I've already written down, but I'll write it down again. We have 4 suits in each of those. We could be asked about picture cards. Picture cards generally refer to the Jack, the Queen, the King, and the Ace. Okay. And realistically, that's all we really need to know. That's the main sort of part of it. Remember, we don't really use the joker cards unless we're told to otherwise. So for example, to finish us off, it might say, what's the probability of getting a red queen? Now, if I go back as a recap, the favourable outcomes, well, there are 2 red queens. There's a queen of hearts and a queen of diamonds. There are 52 cards in a normal deck. Therefore, there is 1 in 26 chances. What's the probability that I get, let's say, a 7? Well, there are 4 7s in a normal deck of cards. Therefore, I have 1 in 13 chances. They might say that what's the probability of getting a king of hearts? Well, there's only 1 king of hearts in the normal deck of cards. We get 1 in 52. Look, again, have a crack at these questions. That's a pretty good wrap up of what it is. Probably a bit too much than what you need to know, but have a crack at the questions in the exercises in your particular textbook. Any questions, drop me a line. Otherwise, have an awesome day.